So what we're going to talk about today is how we take the derivative of more complicated functions. So last time we were talking about basic differentiation rules and how they can speed up the process of taking a derivative over using that limit definition that we were using before. And now we're going to start talking about more complicated functions. So today's question is, how would you take the derivative of something that looked like f of x equals x squared times the sine of x? Now most people's initial reaction is to just say, well, I would take the derivative of x squared, and then I would take the derivative of sine, and I'd multiply them together, and that would be my derivative. Well, if we went through the proof of this and we applied the limit definition to this function, we'd see that that's actually not the case. We're not going to go through the proof today because it's time consuming and your professor is probably going to go through it, or it's probably in your textbook, or you could find it online. You're just going to take my word for it. But what we're going to talk today is about the product rule. So the product rule is a differentiation rule or a derivative rule for when we have the product of two things going on. So what the product rule says is given any two differentiable functions, f of x and g of x, meaning that we have two functions that we know how to take the derivative of, the product of these two functions is also going to be differentiable, meaning that we can take the derivative of the product of these two things. And then we have these two different formulas on the board. They're the same formula, just two different ways to write it. There's a lot of dx's going on and all of that. So personally, I prefer this bottom one down here. I think it's a little cleaner and easier to memorize. So all the product rule says is if you want to take the derivative, or d dx, which is what this symbol means, is it's the derivative. So your professor is probably using that in class, or your teacher, whoever's teaching you this. Your book probably uses d dx's as well. So the derivative of f of x times g of x is just going to be g of x times the derivative of f of x, or f prime, plus f of x times g prime, or the derivative of g. The way I like to say it is the derivative of f times g is just the derivative of the second, is the second function times the derivative of the first, which is what this g times f prime is, plus the first times the derivative of the second. And that's just how I like to say it. I think a great way to help you memorize this is just to say the product rule over and over again. Write it down a bunch of times, say it out loud to yourself, and every time you go through a problem where you have to use the product rule, a great idea is to start off by the top of the problem, just writing out what your product rule is. It's a great way to get it stuck in your head. So now, before we get into examples, I just want to make sure that this is really clear. The most important thing to take away from today's video is that the derivative of the product of two functions is not the product of the derivatives of each of the functions. So box that, make it really stand out. That's the most important thing. So when you see the product of two things, don't just go, okay, I'm going to take the derivative of the first and then multiply by the derivative of the second, and that's going to be my answer. It's not going to be your answer. It's going to be a way for you to lose a lot of points on tests and quizzes. So the first example we're going to do it two different ways. The first way we're going to do it is we're going to actually FOIL those two quantities that f of x is equal to together, and then take the derivative using our power rule and see what that equals. And then we're going to apply the product rule to it and see that we get the same thing. Show you why the product rule works a little bit. So first we're going to FOIL those two quantities together to find out what f of x is equal to, what the polynomial is. So doing that real quickly, we get 15x plus 12x squared minus 10x squared minus 8x cubed, which if we simplify it, we get 15x plus 2x squared minus 8x cubed. Okay, so now we're just going to take the derivative. We're going to find f prime of x. To do that, we're going to use our power rule. So the derivative of 15x, bring down that 1 as an exponent, it's just going to become 15 plus 2 times, bring down that exponent, we're going to get 4x minus, first we're going to subtract that 1. We're going to get x squared, bringing down the 3 as a coefficient, we're going to get 8 times 3 is 24. So that's our overall derivative for f of x. So now let's go over and apply our product rule. So the derivative of the product of two functions f and g is just g times f prime plus f times g prime. So if we go back up to that original function where it's written on the top of the screen, we're going to let the first one be f and the second one be g. So before we go plugging into this formula, let's actually find what f prime and g prime are. So f prime is just going to be 3 minus 4x using our power rule again. And g prime is just going to be 4 since the derivative of a constant that 5 is just 0. So now we're going to plug into our formula and find f prime of x. So the first thing we do is g times f prime. So g was 5 plus 4x times f prime, which is 3 minus 4x, plus f, so 3x minus 2x squared times 4 for g prime. Okay, so now we're going to FOIL these together, distribute, and combine all of our like terms, see what we get for f prime. So just FOILing through the first two quantities, we're going to get 15 minus 20x plus 12x minus 16x squared. And then distributing that 4, we're going to get plus 12x minus 8x squared. So combining our like terms, we're going to get 15 minus 20x plus 12x is negative 8x. Negative 8x plus 12x is plus 4x. Then negative 16x squared and negative 8x squared is going to give us that negative 24x squared. So now we can see that these two things right here, they're equal, which is exactly what we wanted them to be. So two different ways of taking the derivative of that same function, one using FOILing and then the power rule, and then one using your product rule. They're going to give us the same answer, in other words. So now let's try some example problems where we can't do that. We can't just FOIL them together and then take the derivative with the power rule. And we're going to go back to that first example that we had, that f of x equaling x squared times the sine of x. So again, let's write our power rule up on the board. So we got d dx of f times g. It's going to be g times f prime plus f times g prime. Okay, so let's let x squared be that f and sine of x be our g. So that means that f prime, using our power rule, is going to be 2x, and g prime, using our derivative properties of the trig functions, is just going to be cosine of x. Okay, so let's plug in now to find f prime of x. So f prime of x is going to be g times f prime. So g was the sine of x. Put some parentheses around there. And f prime was 2x. Plus f, so we got x squared times the derivative of g, which was cosine of x. Okay, so now we'll just maybe rewrite the term a little bit to make it a little more organized, neater to look at. So our derivative is going to be 2x times the sine of x plus x squared cosine of x. That's our final answer. So that's how the product rule is always going to go. You always want to make sure you write down which one you're considering to be f, which one you're considering to be g, and to make sure you plug into your formula correctly and simplify if you can, and if not, rewrite it so it just looks a little nicer. So one more example for you today. We've got f of x equaling x squared times the sine of x times the cosine of x. So we got two products going on, which means that we're going to have to use the product rule twice. So you might run into problems like this. They get a little bit more complicated as you keep going on through a section. So again, we'll write our power rule up on the board just to get that stuck in our head again. So derivative of f times g is g times f prime plus f times g prime. Okay, so now we've got a little bit of a problem here because we have three functions and our product rule only has two in it. So what we're going to have to do is we're going to have to split this somehow. So let's split it first here. So let's let x squared be our f and then this whole sine x cosine of x be our g. Okay. So finding f prime is really easy because it's just x squared. So using our power rule we get 2x. But now we're going to do g prime. To do g prime, we have to take the derivative of sine of x times cosine of x. So g prime is equal to this. Which means that we have to apply our power rule again. So here, let's let little f be sine, and little g be cosine, and let's find this here, and then we'll plug in to find g prime, this first g primes. Maybe we'll put subscripts on these to differentiate them. So the derivative of f1 sine of x, well, derivative of sine is cosine, and then the derivative of g1 is derivative of cosine, which we know to be negative sine of x. Okay. So what this means now is that our overall g of prime, plugging back in for this one, we know it's g times f prime, so g was cosine of x times f prime cosine of x, plus f, which was sine of x, times g prime, which is going to be times negative sine of x in this case. So to draw arrows to show where all these things are coming from, so there's a lot of arrows on the board there. So we're applying the power rule inside of finding out our overall power rule, so finding out this g prime. So if we simplify here, we get that g prime is equal to cosine squared of x minus sine squared of x. And now that we know that, we can go back up and find our f prime of x for our overall function. So f prime of x was just g times f prime. Okay, well our original g function was sine of x times cosine of x. And f prime was going to be 2x. Okay, so now we have that, plus f, which was x squared, times g prime, which we just found out to be cosine squared of x, minus sine squared of x. So now all we have to do is simplify a little bit. We'll see what our final answer is. So we're going to get that this is just 2x sine x cosine of x plus, distributing the x squared, we get x squared cosine squared of x minus x squared sine squared of x. There we go. So we're going to leave it at that. That's going to be our derivative. You could even leave it up here at this first line. You could leave your answer as this whole thing, but sometimes it's a little nicer just to multiply through and see what it all is. But other times it's nice just to leave it factored out. It might be easier to work with when we get into starting to analyze derivatives. Okay, so thank you so much for watching. I hope this helped you to understand the product rule of differentiation a little bit more. Have a great rest of your day.